Hey guys.
Welcome to week 6. We only have 2 new lessons and a review worksheet, and then we're done with chapter 11 and we're moving on. You guys got this.
Hang in there. We will have one review worksheet at the very end, which is going to have everything. So remember, you guys have access to all the old videos, all the old notes, and hopefully you have all your homework. So if you're struggling on a specific problem, check out the old things or zoom with me and Miss May. All right, see you guys soon. All right, guys, so remember, we are at week 6. So on the homework for this lesson, let's go ahead and put week 6 at the top of it. So 11.5 part 2, I'm continuing with what Miss May taught you from last time. So to review what she taught you, we need to get the same denominators. So our LCD will be the r minus 1 and the 3, okay? So I'm going to go ahead and rewrite it. R plus 1 over r minus 1 equals r over 3 plus 2 over r minus 1. So this one we're going to need to multiply by 3 by 3. This guy is going to need an r minus 1, and this guy needs the times 3, okay? So on top we're going to have 3 times r plus 1 over 3 times r minus 1 equals r times r minus 1 over 3 times r minus 1 plus 6 over 3 times r minus 1. As you can see, they all have the same denominator, so we're going to go ahead and scratch it out. Okay, I'm going to distribute here. So I'm going to have 3 times r, which will be 3r, 3 times 1, which will be a plus 3, equals, we're going to distribute this, so that's going to be r times r, which is r squared, r times a negative 1, which is a negative r, and plus 6. Remember, from here you want to get everything in standard form and setting it equal to 0. So I'm going to subtract 3 and subtract 3r. So 0 equals r squared. A negative r subtracting 3 more is a negative 4r, and 6 minus 3 is a plus 3. From here you're going to factor it. So 1 times 3, that makes a negative 4. That's going to be a negative 3, negative 1, divide by our a value, which is a 1r, 1r. So we have 0 equals r minus 3 times r minus 1, okay? We're going to set them both equal to 0. So r minus 3 is equal to 0, and r minus 1 is equal to 0. This one we add 3 to get r equals 3. And add 1, r equals 1. And then real quick, remember, if it asks to check for extraneous solutions, we should be doing that. As you see, our original denominator had r minus 1. So if I was to plug in 1, that would get 0. So that is going to be our extraneous solution. Okay, so that was a long bell work to start. Any questions, Miss May? Any comments?
Looks good.
All right, first type of problem on part 2 is going to be, okay, so the word problem that we're going to be doing is 2 people working together. So again, me and Miss May are working together to complete a project. We all know Miss May works faster than I do, so she can do a job faster, but if we work together, we're going to both complete the job faster. Whenever you are having a working together problem, you are going to be using this formula. Okay? It states t over the time 1 plus t over the time 2 is equal to 1. And we are going to be solving for the variable t at the top. So in the first problem, Amy paints an apartment in 7 hours. Jeremy paints it in 9 hours. If they work together, how long will it take them to paint an apartment of the same size. So they're trying to together paint one apartment, okay? So our variables will be t over, okay, Amy's time was 7 plus t over Jeremy's time was 9, and they're going to equal that to 1 apartment. So again, you can put everything over 1. We have an LCD. 9 times 7 will be 63, okay? So we're going to times this guy by 9 and 9, this by 7 and 7, and this guy by 63 and 63. We have 9t over 63 plus 7t over 63 equals 63 over 63. We may now scratch our denominator. 9t and 7t will give us 16t to equal 63. Again, we are solving for t, so divide both sides by 16, and t will be approximately 3.93 hours. Now, the hours that they originally did were 7 and 9, so for our answer, we will round it to t is approximately 4 hours. Okay, the next type of example, solving proportion problems. This is cross multiply, okay? So cross multiply, 4 times x plus 1 equals 3 times x plus 2. Distribute 4x plus 4, distribute 3x plus 6. You're solving for x, subtract 3x, x plus 4 equals 6, subtract 4, x equals 2. So that one's not that bad, right? So go ahead and flip onto the back side. And the problem that you all try right now will be 6 over x plus 5 is equal to x plus 3 over x plus 5. Go ahead and stop the video and try it now. All right, so remember with cross multiplication, we're going to do x plus 5 times x plus 3 equals. Remember, we want this entire binomial to multiply by this entire binomial, so we're going to put it both in parentheses, and this will be a FOILing case. Equals our 6 times, again, the x plus 5. Since it's binomial, we're going to put in parentheses. That way, remember to distribute to both terms. So FOILing, f times f is x squared. Our outsides will be a 3x. Our insides will be a 5x. Our last times our last will be a plus 15. To equal, distribute. 6 times x is 6x. 6 times 5 is plus 30. All right, putting it in standard form, we will subtract 6x, subtract 6x, and then we will go ahead and subtract our 30, subtract our 30. That will be equal to 0. We're going to have x squared. 3 plus 5 is 8. 8 subtracting 6 is a positive 2x. 15 subtracting 30 is negative 15. That is going to be a factoring problem. 1 times negative 15, that makes a plus 2. That will be 5 and 3, with the 5 being positive, the 3 being negative. Divide by our a value, which is a 1x, 1x. So we are going to have x plus 5, parenthesis, x minus 3, parenthesis, equals 0. Setting them both equal to 0, x plus 5 equals 0, x minus 3 equals 0. Subtract 5 to get x equals negative 5. Add 3 to get x equals 3. Again, there is an extraneous solution. Remember, our original denominator was x plus 5. So if we plug in a negative 5, that's going to give you a 0, which is undefined. This is extraneous. Okay, next example. It says, solve each equation, check your solution. This is different than cross multiplication. We are going to start with putting the negative 2 over 1, and we are going to try to get our common denominator and scratch out the denominator. So our LCD will be an r minus 4 and an r plus 5. I'm going to go ahead and rewrite it. 2r over r minus 4 minus 2 over 1 equals 4 over r plus 5. R minus 4 needs the r plus 5. This one needs both. So r minus 4 and r plus 5. R minus 4, r plus 5. And our last one needs the r minus 4. Okay, rewriting it. We have 2r parenthesis r plus 5 over r plus 5, r minus 4, a minus 2, r minus 4, r plus 5, over r minus 4, r plus 5, equals 4r minus 4 over r plus 5, r minus 4. Okay, we can now scratch our bottom. On the top, we can distribute. 2r times r is a 2r squared. 2r times 5 is a plus 10r. I'm going to leave the negative 2. And then I'm going to go ahead and FOIL. R times r is r squared. The outsides are a plus 5r. The insides are a minus 4r. And the last is a negative 20. Equals, distribute, 4 times r is 4r, and 4 times negative 4 is negative 16. All right, start cleaning some stuff up. First of all, this is going to become a 1r. So 2r squared plus 10r, distribute, distribute, distribute. So negative 2 times r squared is negative 2r squared. Negative 2 times r is negative 2r. Negative 2 times negative 20 is plus 40 equals 4r minus 16. We're still not done. Getting close though. All right. We are going to subtract 4r minus 4r. Add 16, add 16. This will be set equal to 0. Combine some like terms. 2r squared, negative 2r squared. Those are gone. Thank goodness. Okay. 10r, a negative 2r, and a negative 4r. So 10 minus 2 is 8. 8 minus 4 is 4r. Lastly, 40 plus 16 is plus 56 equal to 0. Subtract 56. 4r equals negative 56. Divide by 4. R equals negative 14. Go ahead and try that next one. 3 over s minus 1 plus 1 equals 12 over s squared minus 1. Good luck. All right, so first thing we need to do is find what our LCD is. Let's look at what s squared minus 1 is, because the s minus 1 might be a part of that. Remember, this is the square root method. So that is actually s plus a 1, s minus a 1. That will be our LCD, okay? So s plus 1, s minus 1 will be our LCD. All right, I'm going to go ahead and rewrite it. 3 over s minus 1 plus 1 over 1 equals 12 over s plus 1, s minus 1. So, on the 3 over s minus 1, we need the s plus 1, s plus 1. This one needs both of them, s plus 1, s minus 1, s plus 1, s minus 1. The 12 over s plus 1, s minus 1 already has the LCD, so we don't need to change that. Starting from the left, we have 3 times s plus 1 over s plus 1, s minus 1, plus we have s plus 1, s minus 1 over, oh no, I'm running out of room, equals 12 over s plus 1, s minus 1. All right, fun part, scratch the denominators. On the top, we have 3 times s and 3 times 1, so 3s plus 3 plus. I do not need to FOIL out s plus 1 times s minus 1 because I know that it was s squared minus 1. So I'm going to have plus s squared minus 1 equals my 12. Let's put it in standard form, starting with s squared. We have a 3s, and we need to subtract our 12 to equal 0. So we have 3 minus 1 is 2. 2 minus 12 is a negative 10. Okay, let's factor. 1 times negative 10, that makes a plus 3. That will be 5 and 2. With a plus 5 and a minus 2, divide by the 1s. So s plus 5, s minus 2 equals 0. Set them both equal to 0. S plus 5 equals 0. S minus 2 equals 0. Subtract 5. S equals a negative 5. Add 2. Okay. Looking back, negative 5 and 2, back at our original equation. If you check your denominators, none of those would give you a 0, so those are both correct solutions. Again, me and Miss May, we will have Zoom hours this week on Wednesday and Thursday at 12 and 1:30, so just email us if you need any help, please. Good luck.